Okay. So last time we done case 3 का, right? Case 3 का base में questions we are doing. Okay. चलो. करो. A proton charged particle mass is given also, is shot with a speed this much at certain angle 37 degrees with the x-axis. So x-axis से 37 degrees से मैं फेंका in a uniform magnetic field. Definitely, whenever there is a uniform magnetic field, में charge is moving means there is a force along the axis. Find the radius and pitch of the helix. Because when we are throwing at certain angle, definitely it is going the helix path. So it's telling pitch of the helix and radius also. So charge Q, x-axis, y-axis, z-axis. If I'm throwing with some velocity at certain angle, 37 degrees. Charge को. A magnetic field exists along the x-axis. So magnetic field is in the x-axis. This is a magnetic field. So magnetic field, this was magnetic field, right? So magnetic field से angle 37 degrees में it is throwing with some velocity. Therefore, definitely helix path, helix में circular भी रहेगा, straight भी जाएगा. Radius find करो. Formula is mv perpendicular by qb. साथ ही मालूम है परपेंडिकुलर वाला मैग्नेटिक फील्ड से परपेंडिकुलर वाला v sin थीटा वो लेने का, वो वाला वेलोसिटी शुड टेक. हाँ.
Sir, R is approximately 0.1.
Yes, 0.1 meters. Yes, correct.
So pitch is approximately 0.8.
पीछे आ गया क्या? 0.8 24 3 हाँ correct 0.8. So here everything is given. V perpendicular will be v sin theta, मतलब v sin 37. So जो value आया v is given, right? So value आया, substitute here, we'll get the answer. And time period दूसरा क्या है? Pitch, right? Pitch is v parallel into time period. V parallel in this case में v cos theta. So v cos 37 into time period is 2 pi m by qb. देखो पाई पाई रहने दो, नो प्रॉब्लम. इन टर्म्स ऑफ पाई में और फ्रैक्शन में यू कैन टेल. ओके. तो आंसर अप्रोक्सीमेटली 8 pi by 30. 8 pi by 30 meters. सिंप्लीफाई और भी कर सकते हैं, राइट? चलो नेक्स्ट. A particle with a charge and mass moves with a velocity. Now देखो the velocity it is having two dimensions in a magnetic field. Magnetic field is in along the x-axis, x direction. I cap दिया ना. Find the radius and pitch. Radius and pitch. करो. So x-axis, y-axis, z-axis. So plus q charge है. I am throwing with velocity 3 I cap plus 4 j cap. Okay, and b is along the x direction. 10 Tesla. Now in this case में definitely it is going certain angle में है ना ये magnetic field. Definitely it will go in a helix path. Therefore radius and pitch रहेगा.
Sir, R is 2 by 5 m by into m by q.
Okay.
And pitch is 3 by 5 into pi m by q.
अरे ये सब कुछ पहले मतलब ऑलरेडी आंसर से अभी किया.
Yes, sir. I did it now.
गुड। आया सात्विक आपको भी?
Yes, sir.
इधर परपेंडिकुलर वेलोसिटी क्या डालेगा टेल में?
So 4j gap.
4j क्या? why 4j क्या? because y is perpendicular. Okay, now देखेंगे। ये करो, ये मिस्टेक करेगा मेरे ख्याल से। डायग्राम ड्रॉ करो, अंडरस्टैंड एंड सॉल्व। A particle with charge mass, it is moving with velocity I and j, and now b is in 10 k cap. Okay, find the radius. X-axis, y-axis, z-axis. So z is coming towards you, right? So now magnetic field is along k cap. Matlab it is along like this, right? Outside. And I am throwing with velocity 6 I cap plus 8 j cap. Now लगाओ R पेंट करो, mv perpendicular by qv. Now perpendicular velocity क्या रहेगा?
So the velocity itself is perpendicular. 6i plus 8j.
Okay, मगर क्या डालने का इधर, क्या डालने का?
Unit
देखो,
vector.
this 6 I cap and 8 j cap, right? 8 j cap. So this total velocity is perpendicular to the magnetic field. So इसका resultant velocity you have to put.
Sir, m by q.
M by q, very good. So 8 6 का resultant under root 8 square plus 64 plus 36, it is 10. So R is equal to m into 10 by qb. B is much 10. So m by q is on. So आपको that's why we are not learning v cos theta v sin theta. We should learn v perpendicular. Then it is safe zone. कभी कौन सा velocity should be perpendicular वाला velocity लेने का, दोनों है तो resultant find करके solve करने का, right? An electron is accelerated by a potential difference is given this much, moves in a uniform magnetic field at an angle 60 degrees with the field 91 millitesla. Find the pitch of the helical trajectory of the electron. So magnetic field मान लो ऐसा है. Okay, I am throwing a charge with some velocity at angle 60 degrees. Okay. Now he's telling what is the pitch. So pitch का formula है v parallel into time period. So time period के लिए पूरा है क्या? He talking about the electron. Electron का mass मालूम है. So what is v parallel into time period is 2 pi m by qb. b दियन चार्ज मालूम है, इलेक्ट्रॉन का मास आल्सो मालूम है, टाइम पीरियड तो पूरा मालूम है ना. नाउ v पैरेलल चाहिए. v पैरेलल कैसे आएगा? वेलोसिटी कैसे आएगा? They given in terms of potential difference. I told you last time, right? Potential, if the charge is accelerating through a potential difference, we can use work energy theorem. From that we can get velocity. Fine, go. It is accelerating through a potential v. Electron is accelerating from here to here. So what is the potential difference का definition क्या है? V minus 0. V is equal to work done by charge. So W is equal to QV. Okay, this here V is what here? Velocity नहीं, either potential difference. Okay, and this is equal to kinetic energy, changing kinetic energy. Final minus initial 0 है. So kinetic energy you got as QV. and therefore half mv square, because when it's accelerating it has some velocity rate. Half mv square is equal to qv. So from this v is equal to 2qv by m under root, right? Here v is potential difference. इसका स्पीड मैग्नीट्यूड स्पीड मान फाइंड करो सबस्टिट्यूट. So under root 2 into 1.6 into 10 power of minus 19 into potential difference is how much? 4.5 kV. So 4.5 into 10 cube kilovolt upon mass. Mass is 9.1 into 10 to the power of minus 31 kg. Right? ये वाला solve किया तो approximately you will get as 4 under root 4 into 10 power of 7 आएगा. 4 into 10 power of 7 meters per second velocity. Speed आ जाएगा ना. और सबस्टिट्यूट करो 4 into 10 power of 7 into 2 pi m by qb. In terms of yeah, pi में बोल दो हो जाएगा pitch में. And v parallel means मालूम है ना, we got velocity got right. Now v parallel बोलते कौन सा यूज करेंगे? ये वाला, उसका cos theta वो यूज करेंगे. So v cos theta into 2 pi m by qb. v मालूम है आपको स्पीड है, उसका cos theta
So nearly 80.
nearly 80 या
Yes.
भाई nearly pi में बोलो, pi terms में बोलो ना बोलो.
I calculated
स्पीड दे
everything.
दिया मैं इसलिए ठीक है. So 4 into 10 power of 7, 4 into 10 power of 7 into cos 60. Cos 60 is 1 by 2 into 2 into pi into mass is 9.1 into 10 power of minus 31 by 1.6 into 10 power of minus 19 into magnetic field is 91 milli. 91 into 10 power minus 3. ठीक है, टाइम वेस्ट मत करो. इसका कैलकुलेशन अप्रोक्सीमेटली विल गेट एस pi by 4 into 10 power minus 2. These are meters, distance and pitch. तो मेरा सो मेथड समझो, कैलकुलेशन तो इजी हो जाएगा, थैंक्स नहीं. चलो नेक्स्ट. सो ये टॉपिक डन फॉर अस. ओके, कौन सा 3 केसेस का डन. नो, लॉरेंस फोर्स के बारे में डिटेल में, थोड़ा डिटेल में कर रहे हैं. उसमें क्या आएगा आपको, यू नो वेलोसिटी सिलेक्टर बोल के एक टॉपिक रहेगा, दैट इज इंपॉर्टेंट. वेलोसिटी सिलेक्टर बोल के सुना होगा ना नाम, वेलोसिटी सिलेक्टर बोल के सुना है नाम? यस, याद है वेलोसिटी सिलेक्टर मींस? एनी आइडिया व्हाई वी आर यूजिंग वेलोसिटी सिलेक्टर, क्या है बोल के? नो, ओके चलो, नो प्रॉब्लम. चलो, now motion of a charged particle in both electric and magnetic field, and this force is called as Lorentz force. And formula मालूम है ना, इलेक्ट्रिक फोर्स का फॉर्मूला QE and magnetic का Q into V क्रॉस B. दोनों को वेक्टोरियली ऐड कर रहे हैं by using Lorentz force. Okay, चलो. now इसमें क्या करेंगे, we will divide into some cases. Okay, देखो E and first case E and B are parallel. मतलब क्वेश्चंस कैसा आएगा अप्रोक्सीमेटली ऐसा डिफरेंट केसेस टाइम्स में आएगा. वी आर सीइंग, देखो E and B are parallel to each other. मतलब देखो, here both electric field is there, magnetic field is there. What is the angle between them? Theta is 0 degrees. Both are parallel to each other. In that case में I am throwing a charged particle of mass m with some velocity v naught in both electric and magnetic field. Now इसमें क्वेश्चन क्या है, फर्स्ट इलेक्ट्रिक फोर्स कितना एक्ट होगा? इलेक्ट्रिक फोर्स इज हाउ मच? इसके ऊपर सिंस मास m इज इन इलेक्ट्रिक फील्ड, उसके ऊपर फोर्स लगेगा QE. सो फर्स्ट वन इज QE. मैग्नेटिक फोर्स कितना है टेल में? magnetic force in magnetic field say parallel it is going, angle is 0 degrees. So what is the force?
0.
0. So magnetic force is 0. So net when there is an electric force QE तो definitely there is acceleration also. Acceleration क्या क्या आएगा? F by m. So QE by m आएगा. So since there is magnetic force is not there, electric field का direction only acceleration is there. उसी direction में the particle will go. So what is the trajectory? Trajectory क्या होगा? It will go in a straight line. With देखो electric field is constant, mass of electron is constant, charge is constant. It will move with a constant acceleration, variable acceleration, the particle. Tell me. Q constant है, E constant है, M constant है, acceleration is constant. So it will move with a constant acceleration, right? That means I can tell straight line path with constant acceleration. So questions कैसा आएगा? Advance में they'll give this scenario. They'll tell the graph, which of the following graph is the matching बोल के. So it is constant बोल के आपको समझ में आने का by using the equation. Since only electric force is there, we are trying to find force and acceleration from this. So models are there, way of asking questions कैसे बोल के. तीनों चैप्टर से मैग्नेटिज्म का, मूविंग चार्जेस मैग्नेटिज्म, मैग्नेटिज्म मैटर एंड इलेक्ट्रोमैग्नेटिक इंडक्शन, तीनों मिलके कंप्लीट मैग्नेटिज्म बनेगा. अच्छा रहेगा मैग्नेटिज्म. इलेक्ट्रोस्टैटिक्स भी अच्छा है, मैग्नेटिज्म में आल्सो थोड़ा फॉर्मूला बेस्ड है, थोड़ा डायरेक्ट कर सकते हैं. माय तो कौन सा रूल है? राइट हैंड पाम रूल है, राइट हैंड थंब रूल है. दैट्स इट. ओके चलो नाउ करो. State the path of the particle and displacement of the particle after t seconds, at t seconds. Initially object is at rest, मतलब object means charge is at rest of mass m. Both electric and magnetic field are parallel to each other. He is telling what is the path. Tell me first path क्या है? It is a straight line
Straight line.
path. Now displacement find करो. Magnetic force तो 0 है, electric force तो QE, and acceleration is QE by m, and initial velocity is 0. S finding displacement after t seconds, time is t. So use the equation of motion and tell me which one is right. So क्या सा यूज करेगा? ut plus half at square. So u is 0. So s is equal to half into a के जगह में QE by m into t square. So he can give which of the following graph is true बोल के, like ऐसा t square. So based on the graphs they can convert anything. So डरने का ग्राफ बोलता है इधर से कैसा लेके आएगा, kinematics ऐसा नहीं. You try to form the equation, check which graph is matching बोल के. Okay, next. Okay. नहीं करो. Find the path or trajectory of the particle. Find the path or trajectory of the particle. देखो charge now entering perpendicular to electric and magnetic field. See case to same only. देखो electric field, magnetic field are parallel, but the charge is entering perpendicular. So now tell me which path it will take.
Elliptical.
Elliptical, huh?
Yeah.
Why elliptical?
Because it's there is a straight line motion and there's circular motion because V is perpendicular.
उसको elliptical नहीं, helical बोलते हैं. Helical.
Okay, yeah. Fine.
Helical path, yes, helical path. Okay. देखो electric force के वजह से QE is a formula, charge Q, and electric force is acting along the x direction, y direction. Electric force will be there in x direction, y direction. See, electric field is along the x direction, so force will be x direction only. If the electric field is upwards, the charge also moves upwards only. Wherever electric field direction is there, उसी direction में charge will move, right? Because positive charge है ना, it will move in the same direction that of electric field. So it is along the x-axis. Okay. Now magnetic force मैग्नेटिक फोर्स का क्यू वी बी साइन थीटा, वेलोसिटी एंड मैग्नेटिक फील्ड का एंगल इज 90, सो साइन 90, so it is QVB. Okay, direction bolo, which direction the this magnetic force is acting? Right hand palm rule lago.
Inwards.
ये four fingers will
Minus
be
sign.
magnetic field, ऊपर नहीं outwards positive charge है ना, देखो magnetic field ऐसा, and the thumb indicates the direction of the positive charge and force is inwards, right? So along the negative z direction ना, positive z direction ना,
Negative side.
along the negative z direction. This also important है आपको directions. Okay. Now इन दोनों को resultant will be in which plane में रहेगा? Which plane में मिलेगा आपको resultant? Definitely helical जाएगा, right? मतलब ये it said it want to go in the positive x direction and negative z axis में. So which plane में रहेगा? If you see from the side view में और उस तरफ से देखें तो which plane? And here force है तो definitely there is acceleration, right? Acceleration Fe by m, it is QE by m. देखो पार्टिकल नेगेटिव एक्स एक्सिस में फोर्स लग रहा है, नेगेटिव जेड एक्सिस में फोर्स लग रहा है इनटू द बोर्ड, एंड ये पॉजिटिव डायरेक्शन में जा रहे हैं, मतलब आपको देखने से आपको वाई जेड प्लेन में मिलेगा, वाई जेड प्लेन में से आपको मिलेगा हेलिकल पाथ वाई जेड प्लेन में. सो रिजल्टेंट विल बी इन वाई जेड प्लेन एंड द रिजल्टेंट ट्रैजेक्टरी इज हेलिकल पाथ, ऐसा रहेगा. ओके, यू टेल मी हियर द pitch will be same or different? Suppose this is P1, this is P2. What is the relation between P1 P2 in this case में? P1 P2 will P3 मान लो. हेलिकल पाथ टोल इन दिस केस में. सो हेलिकल पाथ में पिच के बारे में बोलो, रिलेशनशिप P1 P2 P3. इक्वल और ग्रेटर और लेसर एनीथिंग? हॉरिजॉन्टल एक्स एक्सिस में there is a acceleration. What is meaning of acceleration? Every second में velocity is increasing, speed is increasing, particle का charge. So कैसा रहेगा मालूम है एक्चुअली? ये ऐसा रहेगा, सेकंड पिच में ऐसा रहेगा, थर्ड पिच में ऐसा रहेगा. So P1 because velocity goes on increasing, right? P2 P3 मतलब here P3 is greater than P2 greater than P1. This is answer. So आपको they can ask any type of questions in this type of cases. मैग्नेटिज्म में नाइसली फॉर्मुलास पढ़ के टेस्ट लिख रहा आज टिल 10 o'clock तक, इवनिंग 10 o'clock तक ओपन है. उसमें कुछ भी डिस्टर्बेंस नहीं है तो उसी टाइम में ओपन करो, ट्राई टू फिनिश कंप्लीटली एंड सॉल्व. ओके, चलो नाउ विल गो फॉर सेकंड केस. सेकंड केस बहुत इंपॉर्टेंट है, वेयर इलेक्ट्रिक फील्ड एंड मैग्नेटिक फील्ड आर परपेंडिकुलर टू ईच अदर. अभी तक क्या है? पैरेलल, दोनों पैरेलल है. अभी परपेंडिकुलर टू ईच अदर. देखो इफ यू सी the electric field is from positive plate to negative plate and magnetic field is inverse. Their angle is how much? Electric field is from positive to negative and magnetic field is like this. So angle is 90 degrees. 90 degrees. Okay. So this is fixed now. Now charge को मैं throw किया inside this direction. Now tell me, because of electric field, which direction the particle will go? Because of electric field is from positive to negative. उसके ऊपर force किस तरफ लगेगा? Downwards or upwards? Because positive charge है ना, electric field is from positive plate to negative plate downwards. So definitely charge के ऊपर downwards act होगा, which is Fe. Right? Okay. Now tell me, because of magnetic field, which direction the force is acting? Right hand palm rule लगाओ. Which direction? Magnetic field is inwards, 4 fingers. And thumb indicates the direction of positive charge and force will be upwards. So magnetic force की वजह से अपवर्ड्स से। मतलब when the charge enter into the field, it has two fields. उसके ऊपर दो force acting. One is because of electric field, because of magnetic field. Now इसमें we have three cases. इसमें सब cases क्या क्या है we will see. Okay. Now first one is if, first case, if magnetic force is greater than electric force, then क्या होगा? Charge will deflect upwards or onwards. If magnetic force is greater than electric force, the charge will deflect
upwards.
So charge ऐसा जाके ऐसा deflect होगा. So Q deflects upwards. Okay, and FM formula is, since they are perpendicular, QVB is greater than QE. So QQ cancel. V is greater than E by V. So V is greater than E by V is a case where magnetic force is greater than the electric force. Then the charge deflects upwards. Now second case, if FM is less than FE, मतलब indirectly electric force is more, that's why charge deflects downwards. Q deflects downwards. So QVB is less than QE. So QQ cancel. V is less than E by V. Less than E by V. Okay. Now third case. If FM is equal to FE, this is a very important case. Charge किस तरफ जाएगा? If both are cancel out each other, the charge will move in a straight line path. Okay. No deflection occurs. Observed. Okay, therefore charge will move in a straight line path. QVB is equal to QE. So cancel. So V is equal to E by B. Very important one. Q is equal to E by B, and this is nothing but a velocity selector. Velocity selector. ये topic के लिए only these all things they will teach now. Otherwise they can skip. But V is equal to E by B. Velocity selector आने के लिए this one. So what is velocity selector means? Velocity selector is very important. V is equal to E by B. Suppose मान लो you have 10 particles are there. 10 particles are there with different speed. Like 2 meters per second, 3 meters per second, ऐसा है. Okay. Suppose I want to collect here. I will put a receiver. I want to collect only 5 meters per second वाला particles only. I want to collect. I don't want 3, 6, 7, 8, 9 particles. I don't want. So many particles there. We can't separate here only. I want to separate here. Then क्या करेगा? आपको what you will adjust? You will adjust electric field and magnetic field such a way that उसका combination will be 5 meters per second. Okay, उसका combination will be 5 meters per second. That means क्या होगा? Exactly 5 meters per second only will go straight because उस 5 meters per second वाला particles को no net force is acting. Only it will reach to the opposite end. But remaining वाला क्या होगा? Remaining particles 2 and 6, 7, 8 वाला deflect हो जाएगा, ऊपर निकल जाएगा. Only this will pass through it. The particles will pass through it. हमें that is called velocity selector. Select कर रहे हैं हम लोग कौन सा velocity चाहिए बोल के. Okay, you know some आपको different particles are there. Alpha particles, beta particles, some particles will be there. So मुझे वो particles चाहिए where it is useful for some cancer treatment के लिए वो particles चाहिए. Okay, वो बहुत mixing together में we can't use that particles and will send in the body. So वो particles correct करने के लिए they will use this velocity selector. Electric field, magnetic field का adjustment करके only will select that particles that speed and they will use in the medical purpose also. Okay, चलो. So formula V is equal to E by B. अगर इसमें net force पूछेगा तो in this case में net force is how much? Net force will be, अगर इसमें तो इसमें net force will be Fm minus Fe is net force, right? Net force कितना act हो रहा है बोले तो इसमें क्या होगा? Net force Fe is greater than Fm, right? So net force is F net is Fe minus Fm आएगा net force. अगर in this case में अगर पूछेगा तो net force कितना पूछे तो we can use this one. When you reading the question, you can imagine, no, ये पूरा याद हो जाएगा आपको. Without studying anything, directly if you read the formula v equal to e by b, खलास, वो डायरेक्ट क्वेश्चन थोड़ी ना आएगा, वो 10th क्लास में आएगा. ये इसमें मीनिंग में उसमें चेंज करेगा बहुत. So understand and then solve. अब चलो ना करो. Very small question है. Velocity selector has electric and magnetic electric field vertically upwards. Okay, electric field is vertical upwards बोला. Electric field is, so diagram draw करो so that you will understand. Okay, electric field is vertical upwards and magnetic field is directed outwards. Magnetic field is outwards. Okay. A positive charge traveling east with a speed, a positive charge है, it is traveling with some velocity v. East में जा रहा है. Enter the velocity selector. It is entering the velocity selector and able to pass completely throughout without any deflected. मतलब it is passing completely in velocity selector में. Okay. Okay. ठीक है इधर तक. So इधर what is the given? Electric field is given, right? 2500 Newton per second. And charge ka velocity is given as v is equal to 6 into 10 cube meters per second. But magnetic field is not given, right? So we can find it is entering into velocity selector, he told. We can find magnetic field. First find the magnetic field. V is equal to E by B. E is given, V is given. Find magnetic field and tell first. In terms of fraction, no problem.
So 5 by 12.
So magnetic field you got as 5 by 12. Okay. Now क्या है? When different particle with charge, now other particle is coming with the charge 4 into 10 to for 12 coulomb. Charge is coming. Enters the velocity selector during east में जा रहे हैं. The net force due to electric and magnetic field acting is 2 into 10 power of minus 9 Newton per second pointing upwards. मतलब indirectly आपको net force means what is the meaning? Fe minus Fm, Fm minus Fe net force here. Because it is acting upwards बोला. Upwards is electric field है ना. That means electric field is more. That means net force is equal to Fe minus Fm. Now net force is how much they given? 2 into 10 power of minus 9 newtons. Directly upwards. What is the speed of the particle? The speed चाहिए. इसका speed चाहिए. Velocity कितना होगा? Okay. Now calculate करो. Fe is nothing but QE minus QVB and angle is 98 sin 90. Now V चाहिए इधर. V find करो. Magnetic field आने के लिए first condition is given. Now other speed वाला particle definitely to deflect. He only told it is going upward. That's why net force is Fe minus Fm. Now take common Q common लेके solve करो. V find करने का. So Q को divide करो. कितना?
Nearly 6,000.
ज्यादा हो गया. No. Nearly नहीं. So Q को divide कर लो. Q is 4 into 10 power of 12, right? So 2 into 10 power of minus 9 by 4 into 10 power of 12. E minus VB. So 2 to the 4. So 10 power of so 0.5 into 10 power of minus 21. 21 is equal to E minus VB. Now bring this side, subtract. Finally, we'll get answer. I'll tell you. 4,800 meters per second. Or 4.8 into 10 cube. 4.8 into 10 cube. If you write in scientific notation. As in scientific notation, greater than equal to A should be greater than equal to 1, less than equal to 10.
So I guess it's minus 12. Coming then only.
Shaja, yeah, maybe. No. But question में they given as yes minus 12. Yes, correct. वो तेरा है, right? So ऊपर गया तो कितना होगा? 3 या 3 plus 3. If you solve, you'll get answer as this much, 4.8 into 10 cube. Okay, charge इतना बड़ा नहीं होगा, minus. Mistake. Good. चलो. Now we have to enter into the new topic, force on a current carrying wire. Force on a current carrying wire. So what is the force on a current carrying wire? Formula याद है? Satvik? And you were not started, right? Satvik, ये chapter? Where they are? Current electricity only?
No, sir, they finished it. They're gonna start new chapter.
Which one? This chapter only?
No, sir. They can say.
Where sometimes some school में they'll go faster, some school में very slow जाने वाला. Okay, चलो. Force on a current carrying wire. देखो, normally we know that force on a charge wire, right? When charge is entering into the magnetic field, we know the formula Q into V cross P. Okay. Now we are seeing the force on a current carrying wire. देखो, इसमें क्या है? A current carrying wire has number of moving charges inside it. Right or wrong? When current is flowing means the charges are moving in magnetic field. That means when current carrying wire is placed in a magnetic field, it experiences a force definitely. Because एक charge enter होने से force लग रहा है. The current is made up of so many charges. So सभी के ऊपर net force is nothing but the force on a current carrying wire. The resultant force on the wire due to magnetic field is a vector sum of the individual forces on the charges inside it. So that's why the rule also will be same. Right hand palm rule only for finding the direction of the force in a current carrying wire. And this actually 10th may they removed before, but this is the principle for motor also. When a current carrying wire, fan क्यों घूमेगा? Magnetic field में when you on the switch, the current is flowing in a magnetic field, it will start rotating because of the force. उसका फॉर्मूला देखेंगे, डेरिवेशन जरूरत नहीं है. तो नेक्स्ट वीक में डन. वी हैव टू स्टार्ट विद न्यू चैप्टर. परफेक्ट करो सीधी. एक अभी इतना हार्ड वर्क कर रहे हैं, वो हार्ड वर्क किधर भी नहीं जाएगा. द पर्सन्स हु आर डूइंग हार्ड वर्क, वो किधर के वो बोलते हैं डॉट्स कनेक्ट होगा बोल के, ऐसा आपको मिलेगा लास्ट में, आपको सफलता मिलेगा. यू नो, इफ यू डू गो ऑन डूइंग द हार्ड वर्क. नेक्स्ट वीक में आई विल कीप ए क्विज फॉर द फॉर्मूला शीट्स का, लाइक 4 चैप्टर्स का, 1 2 3 4. ओके, ये चैप्टर होने के बाद आई एम गोइंग टू कीप द क्विज. ओके, धीरे धीरे आई विल गिव टाइम. प्रॉपर करो, ओनली बाय फॉर्मूला शीट से परफेक्ट आज करो, हो जाएगा. मतलब एक एक बीच बीच में रखेंगे तो आपको आइडिया आ जाएगा, टचअप रहेगा पूरा. ओके, चलो. नाउ देखो फॉर्मूला देखेंगे. आई टोल्ड यू ए मैग्नेटिक फील्ड में आई एम पुटिंग ए करंट कैरिंग वायर ऑफ लेंथ एल. ओके, L is in the direction of current. जनरली वेक्टर L वेक्टर में डायरेक्शन ऑफ करंट बोलते हैं. Okay, at angle theta. At that time, definitely there is a force, because I told you it is made up of positive charges. Current is flowing in this direction, means the charges are also flowing in this direction. And you know, whenever the charges are flowing, there is a force acting in them because of magnetic field, right? So magnetic field ka usi direction of force only the current carrying wire is getting the force. Okay, and formula is F is equal to I into L cross B is a formula for force. Force is equal to I into L cross B. L is the length of the conductor vector, and we should take direction of the current only. L cross B is a formula. If I expand, F equal to IBL sine theta. IBL sine theta is a formula in scalar form. Magnitude. IBL sine theta. Theta is the angle between what? Length and magnetic field. वो theta बहुत भूल जाएगा people. को जो दिया है वो डाल देगा, ऐसा नहीं है. Length of the vector and magnetic field के बीच में angle only we should take. Okay, in this case में length vector ऐसा है, magnetic field ऐसा है, angle between them is theta. That's why we have took theta. IBL sin theta is a formula. उधर क्या था? Q into V cross B, इधर I into L cross B. IBL sin theta. Okay, चलो. And direction के लिए we will use the right hand palm rule only for direction के लिए. And if length and B are perpendicular, what is the maximum force will be acting how much? IBL. Sin it is 1, right? Okay, now देखो perpendicular लिख लो. This was important. If L is perpendicular to magnetic field, so force will be IBL. Okay, and this is the maximum force acting, F max. IBL. Okay, so आपको डायरेक्शन के लिए विल यूज राइट हैंड पाम रूल. राइट हैंड पाम रूल में क्या है? टेल में F4 फिंगर्स का क्या था? मैग्नेटिक फील्ड. थंब का क्या है? उधर डायरेक्शन ऑफ पॉजिटिव चार्ज, राइट? इधर डायरेक्शन ऑफ करंट. डायरेक्शन ऑफ करंट. एंड पाम का रिप्रेजेंट्स द फोर्स. वो पॉजिटिव चार्ज के जगह में करंट लगाने का, करंट कैरिंग वायर. राइट हैंड पाम रूल एक ही रूल यूज कर रहे हैं. मूविंग चार्जेस में एक ही रूल, टोटल चैप्टर में एक ही रूल, राइट हैंड पाम रूल ओनली. ओके, नाउ इसका क्वेश्चंस हम लोग नेक्स्ट क्लास में करने वाला है. इसके डिफरेंट टाइप्स ऑफ क्वेश्चंस डेप्थ में जाने वाला है पूरा. देन विल गो फॉर ए पैरेलल करंट्स एंड देन मैग्नेटिक मूवमेंट, टॉर्क, मूविंग कॉइल एलिमेंट. नेक्स्ट वीक डन चैप्टर पूरा.